In this video, we will talk about one of the most popular communication protocol in the onboard diagnostic OBD2 standard, which is Controller Area Network, along with a brief introduction to CAN. We are also going to take a look at some cool features of our G-Scan tool. Back in the day, when the world was less concerned about environment, there were fewer sensors and modules in the car. At the time, all sensors and modules were connected by point-to-point wires because they didn't need to be linked together for exchanging real-time information. However, as the environment regulation gets stricter, vehicles were required to have more and more sensors and modules to control emission from exhaust pipe. They need to share information real-time to effectively control emission. This meant more wire harnesses were required between modules, and therefore much more weight to the car, more complexity of system, and eventually higher cost. In order to optimize efficiency of network, Bosch came up with a new protocol in 1985 called Controller Area Network. CAN allows different modules to communicate each other using a common cable. As the automotive industry started to adopt CAN, ISO released the CAN standard ISO 11898 in 1993. Later on, ISO added several higher versions. For example, ISO 11898-2, ISO 11898-3. There are more types of CAN bus, but for the sake of simplicity of this video, we are not going to go over all the details of each types. Let's dive into major difference between two mostly used types, high-speed CAN and low-speed CAN. In automotive industry, high-speed CAN has been the most widely used protocol among others, due to its fast transfer rate and simplicity of wires between modules. High-speed CAN allows up to 1 megabit per second and uses a linear bus with 120 ohms termination resistor located at each end, instead of having two termination resistors at the end. In low-speed CAN, termination resistors are located at each module, and its overall resistance is around 100 ohms due to the individual termination at modules. Low speed CAN allows the CAN bus to communicate in case of wire failure. It offers transfer rate from 40 to 125 kilobit per second. When there is a problem in CAN line, symptoms could be ranging from communication error between modules to completely no communication with a scan tool. You may diagnose it manually with a set of oscilloscope, but probing onto cracked pins on OBD ports and analyzing graph can sometimes be cumbersome. But what if your scan tool can check the CAN line with just DLC cable connected? G-Scan 2 offers convenient function to perform simple check for CAN line signal through data link connector. In the utility menu, select communication line inspection. You have options to choose the type of protocol. In this video, I'm going to demonstrate high-speed CAN. You need to set the key on position and connect DLC main cable and hit OK. On the left side, it displays high and low signal pin numbers. You may switch the pin location in setting. Default setting for high line is 6 and low line is 14. If CAN line is in properly working order, these indicators will blink. This is for fast check to see if there is CAN signal, but please keep in mind that it does not represent the correctness of the signals. What if I want to check the waveform of CAN signals? For further diagnosis, you can see live waveform of high and low CAN signal by selecting this waveform button. Up here represent CAN high signal and below represent CAN low signal. It displays voltages at cursor A and B and average voltages of entire waveform. GScan2 offers simple check of termination resistor value without manually probing your multimeter to OBD port. You can check the termination resistor of the CAN bus with simply connecting the DLC cable. This simple check will save your time.